let's begin by moving on to the slide. Okay, today's lesson is slightly different. Okay, now I get the feedback that you guys do not want to try the questions. Okay, so let's do something different. What's that different? I'm going to let you try the questions here now with me. Okay, so but the questions won't be the same that you did in the homework. So don't worry, those very hardworking people who actually listened to me and did the work and prepared, don't worry. These questions I will discuss with you when I can. But today, throughout the class, we're going to do a lot of questions that none of you have seen before, which means it's called unseen. Okay, if it's unseen, then we need to spend a little bit more time to go through the questions slowly. You have time to read and you have time to answer as well, and then go through the answers. Okay, ready? Okay, enough talking, let's start. So to introduce today's lesson, we're actually moving far away from the respiratory system to the circulatory system to the electrical system, right? So the first system that we did was the respiratory system, which are all part of the systems. Respiratory. You need to know how to spell circulatory last week. Circulatory. Okay, even I struggle to spell, but so you need to remember how to spell. You see there's a rat here. Okay. And the rat becomes a lat here. Okay. So you need to notice how to spell, especially if you don't have a rat here, then you have something wrong with the spelling. Respiratory. Okay, and then of course the last three letters is always the same, right? O-R-I, O-R-I. Okay, so this is systems. Systems. So we move away from the body systems, we come to electrical systems. Why are they called systems? Because they are comprised of many things put together to form one system, many components. So many components form a system. The components of a respiratory system, what are they? The components of a circulatory system, what are they? Remember respiratory, we have lungs, nose, and so on. Circulatory, we had what? Blood, heart, blood cells, and so on. Right? What about electrical components? That's what we're going to do today. So let's do. Electricity is a form of, let's fill up together. Those of you who know the answer, help me, type it in for me. Okay, electricity is a form of I like to make things fun. It's a form of energy. Okay, the path through which electricity flows, it must flow. Okay, if you have a wire, electricity will flow, but where will it flow from? You need a battery. That's the energy source. The source is where it comes from. So since electricity is energy, energy. How many of you have watched this guy called Blippi on TV before? Blippi! Hi, I'm Blippi! How many of you watched before? Say yes. Okay. So this guy is really fun, right, on TV, especially younger kids. Whereas for older kids like you guys, I think you should watch Science Max. Okay. So the two YouTube characters that I've introduced you, Blippi and Science Max, all of them do with a lot of scientific stuff. Go and check them out if you have time. Don't always not watch nonsense on YouTube. Since teachers are telling you to watch, you got something to watch, and they're not boring, they're entertaining. So I also don't like to watch boring stuff, Come on. Okay, we have introduced electricity. Electricity is a flow of energy. Okay, let's go. What are the components? Yay, we come with the word across the word components. What are the components similar to if you have a respiratory, you need lungs, you need the nose to breathe in the air and so on and so forth. What about the electricity components? Energy source, yes. The very first thing you'll need is, yes, thank you very much, the battery. If you don't have battery, poof, nothing can go on. Don't have energy to start with, you cannot even start. For example, even your car, right? In your car, you have a battery inside. You don't have even be the toy car or the real car, you need a battery. If the battery is out, you can have the biggest mean machine, Porsche, Ferrari, Mercedes, BMW, it still wouldn't work. it will be a useless piece of metal if you do not have the battery. So it's very important to have the battery. The battery dies. In our phone, our battery dies. Do you know the battery can die in the car also? Okay, many of you may not have experienced the car battery dying, but if it dies, you ask your parents, okay, it will not even move. So Brandon, your dad has a car, right? So ask him, Dad, has your battery ever died? Then he'll be saying, yeah, of course, my phone battery always die, I always charge it. Then he's like, no, not your phone, your car battery. Because rarely people talk about car battery die, right? Okay, car battery can die too, especially sometimes people forget to switch off their engine, switch off their lights, the headlights, and they just go home. And then it's on the whole day. Do you know the battery is consuming the energy to keep the light on? So by the time you come back in the morning, the battery is dead because the whole night you left the electricity going on for the light or the lamp. Otherwise, usually when you're running the car, it generates its own power to actually keep the light on. So your battery can last longer. Okay. Batteries also consist of some chemicals inside them, which is the energy required to give the electricity or the energy. Okay. Okay. What about number 2, number 3, number 4? Anybody? No answers. Everybody give me only the answers for battery. What about the 2nd, 3rd, and 4th? What are the other components that you need to connect? What's this? What am I drawing? A wire. Then, what do you need at the end of the wire? You need something there. What do you need at the end of the wire? You need all right? All right? What is this? Oops, it cannot light up. I'm wrong, sorry, no lighting up. Why? The circuit is not complete. Okay, so we can write bulb here. And we need to complete the circuit by joining the tip of the, you see, this is the metal body and this is the metal tip. The metal tip has to go back to the battery with another wire, and then you complete the circuit. Then you can light up. Ding, 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 ding. It lights up. Okay, so what is the last one you need? Okay, so in order to on and off, you can put a switch. So you put a switch here so that you can control the electricity. So switch. Okay, so it's not on now, right? The switch is not complete. Therefore, I'll take away the light. All right. If you complete the circuit, you can on the light. So if you complete the circuit, you call it a closed circuit. Right? If it's complete, you so call it a closed circuit. If it's not complete, like this one, you see the one that I drew there, it's not complete, it's broken, the switch is not on. What circuit do you call it? Call it an open circuit. Okay, open or close, open or close, that's all. If open, no electricity will flow through, so the bulb will not light up. Okay, carry on. So these are the battery charging signs which we normally see on our phones also. Which one is fully charged? Okay, there's only one which is fully charged, one is 3/4 charge. Now we do a bit of math. This is 3/4 charge, this is half charge, this is 1/4 charge. I think you know your fractions, right? Very good. This one 4/4, which is fully full. Okay, because there's no other, I mean the 4 out of 4 all charged. Okay, wires. Okay, if you really open up, many of you have this concept of the wire being just like a black piece of rubber, but it's not, right? It's actually a copper wire inside the rubber. The rubber is just an insulation to keep you from being electrocuted because there's electricity flowing in the metal. So we don't want you to touch metal, so we put rubber, which is an electrical insulator that will prevent you from being electrocuted, so you do not touch it. So actually, if you really cut it, if you have seen any electrician work on it, you will see copper wires inside the rubber. So that's the main thing where the electricity flows, not the rubber part itself. So please take note, when we when you're going to talk about electricity and its safe uses, we're going to talk about the rubber. The rubber being an insulator, and therefore it's going to help us stay safe. Oh, this stay safe thing is like coming again and again. We know stay safe from coronavirus, but stay safe from electricity has been on forever and ever. Okay, so stay safe is not new. Okay, you got bulb. I've drawn a bulb here or shown you a picture of a bulb. Okay, we usually draw a bulb with simple lines like this, and then we have a tip here, and then we have the glass, and then we have the filament, and so on. Okay, so you need to be able to draw this picture. Since you cannot draw the picture in such beautiful form, so you can draw in a simple form like what I've drawn. So it's not too difficult. You need to be able to show the different parts. You have a glass bulb, you have two parts of the metal, and you have a filament. The filament is what will heat up and light up. It can also blow up if you have too much electricity passing through it. Okay. This looks like I've broken up everything for you. First, I broke up the wire for you. Then I showed you the bulb. Now I'm breaking up the switch. You know the switch that we have at home? Yeah. From the wall, we all look at it. It looks so beautiful. But why is it behind? Okay, it should have a lot of wires coming through as well, running around your walls in order to be able to connect to the power supply. Okay, so that when you plug something in straight away, it connects, right? So the power supply must be always there on your wall. So that's why it's not recommended to be going to touch your wall sockets all the time. Power is on actually. Okay, there are metal connects, so you're not supposed to just stick metal pieces in like forks and all that. You may get electrocuted. So please do not do that. Only electricians who are trained can touch those things. Do not try to screw them out as well. Just because we covered this here and showed you some screws, you are not allowed to screw them out. If you screw them out, I'm sorry, you are the one who's going to be in danger. Okay, and then not only in danger of electrocution, you're going to be in danger of getting a rollicking from your parents. Okay, all right, fill up for me. You guys are very free. I've been talking now. Fill up for me. Come. Brandon, I need you to fill up and participate in this part. Okay, fill up, and then I'm going to call you on, and you're going to tell me the answers to all the blanks here. Okay, Brandon? Okay, Brandon, when you're ready, you can start reading.
Oh, wait. Okay, the electric circuit may be closed or open.
Good.
Closed circuit.
Next.
An electric current can only flow if the circuit is closed or complete. When the components of the circuit are joined to form a complete path for electric current to flow through, the circuit is called a closed circuit.
Very good, Brandon. Thank you very much. Now, look at this. Most of the answers are just closed, right? So let's fill up what Brandon has helped us with. I'm doing it very fast. Open, closed, closed, closed. Everything is closed, closed, closed. Only one open, right? So it's all about closed or open. So the most important sentence will be the second one, where closed circuit, electric current can only flow if the circuit is complete or closed. Okay, so make sure your circuit is complete or closed. Closed meaning all the wires are touching and then there's no opens, there's no switch that's open. Or complete meaning it also should write the touch or rightly or touch the correct parts of the component. For example, the battery, it shouldn't touch any part of the battery. Look at me drawing the battery, right? This is where it should touch and this is where it should touch. Instead, if you touch here, okay, somewhere that is not supposed to touch, then it's not complete either. Right? Should it touch here? Wrong. And then for bulb also, where should it touch? There are only 2 points it should touch. Those of you who have already learned, you know where. Those of you who haven't learned, don't know yet. Okay? So let's have a look. The touch for. Okay? Some of you have actually gone through my lesson in the website. You know what's a touch for. So what are the places you must touch? Battery. Okay? This is touch 1. And this is touch 2. Right? And then the wire goes and you must touch the metal screw looking part over there, and then that is touch 3. And the next one cannot touch from here. This is wrong. You cannot touch the same part because it's just like the battery. Battery has 2 positive and negative poles or components over there, right? Terminals. We shouldn't touch the same terminal. You should touch 2 different terminals where this is the positive, this is the negative. Similarly here, you cannot touch the same part. You must touch the tip, which is here, and then go back and go. So this is 4. This is the 4 touch check, which will complete the circuit, and you got to check that all 4 touches are correct positions. If they are wrong positions, then you're going to have an open circuit. So that was quick, very fast. I drew it also. So we do, you know the answer for this. So the bulb will not light up if, okay, the bulb. Again, I draw for you. You have what? This is the metal cap and the metal tip. Okay, so I'm going to write tip and the cap. Okay, metal, metal. Where's the metal cap? Here. Where's the tip? Here. So the bulb will not light up if either the cap or the tip is not connected to the battery. That's important. So one of them not connected, pop, no light, no bulb, no light bulb, no bulb, no light. Okay, no light from the light bulb, right? The bulb, however, it has also a limit of the electricity that can flow through it. Okay, that's why we call it a rating, or how much amperes or how much power can enter the bulb. If too much goes, what will happen is we call it the bulb fuse. Okay, the bulb will fuse. Okay, too much electric current flows through it and the filament melts. Where's the filament? Here. So there you go. So we talked about the cap, the tip, and the filament. The filament is an important part where electricity or power is generated to heat it up, and such that when it gets very hot, it will light up. Okay, if too much electricity goes, it will just blow and this bulb is spoiled. So we need to protect the bulb from too much electricity as well. So that will also be covered in the safety part in the next few lessons. So circuit diagram, okay, let me complete this. This is just too easy for you. A switch or switches, since it's R here, switches are used to represent the components of an electric circuit. No, not switches. Just because you see S doesn't mean switches. It is symbols. Can you draw for me some symbols that you already know? Actually, I can draw one symbol for you. It's the battery. No, this is not the symbol. This is drawing. What's the symbol of a battery? It's actually like this. How many of you have seen this before? Okay, this means positive and negative. Okay. So can you draw some symbols on your piece of paper that you may have? Anybody want to show me the symbol that you draw on your video? You can raise your hand. I'll try to see if I can see your video. No, not interested. Okay, never mind. Then Mr. Ali will draw everything. Okay, now this will be in your textbook. You can find the symbols. Okay, so a bulb was drawn like what? This. Okay, you don't have to spend too much time drawing this. Okay, a bulb can actually be drawn very easy. How do you draw? This is a bulb. Okay, very simple. So when you draw a circuit, now instead of drawing this and this and this and this, okay, what happened is I can draw this, okay, and this and this, and then instead of, can you see what I'm doing? So this is the same thing. Can you see? So the diagram, which is, this is a drawing, this is a symbol, circuit with symbols. Okay, this is a drawing of a circuit. So you are encouraged to draw with a symbol. That's why you need to draw the symbol. So what's the switch? How do you draw a switch? A switch is just simply like this. So when you close the switch, you probably just draw like that. The switch is already closed. Sometimes you can even draw 2 circles here to show that there's a switch here which was already closed. Clear? So we got switch as well. So what are the names? So we can also write name, battery, bulb, and switch. Okay? All this is just to warm up. Okay, now we warm up already. Now your turn. Today, I'm going to relax as I watch you perform in front of me. All 10, 15 of you who are here, all 15 of you who are here are going to perform and tell me the answers quick. And I need you to type. Okay, I need you to type the answers for each question to me. Okay, question 1. Let's go. Okay, who's got the answer to this question? Anyone? This is about connecting. We already talked about a touch 4, right? So you need to touch at the cap and the tip. So of course, answer is C. I don't have to say too much. What only A, D, and E bulb lights up. Why? B is wrong. C is wrong. And D is wrong, is it? Only A, D, and E are correct. So F is wrong. Why? You can see that they are connected not at the cap and the tip. Okay, for F. And same goes for B also. And goes for C. All right, great. Okay, next one. It's a little bit challenging. There are 6 questions, okay? And each one will take about 2 minutes. So we'll take about 12 minutes to finish these 6 questions. This question is interesting. Huh? You are supposed to play with the switches and you're supposed to find out which switch do you need to open, and then you will have the least number of bulbs. So you need to think critically and try switch by switch. And which one must you remove so that you will have the least number of bulbs? You don't want a lot of bulbs. So your mommy says, putting on too many bulbs is wasting electricity. I have to pay too much. So I want you to only on the least number, maybe 1, 2 maximum. I don't want more than that. So which one do I need to open up? Switch. The switch that connects most bulbs, you open up, then you won't connect them, right? So you can do a few methods. You can try each switch by each switch. You can just take this switch out. So let's, I show you the method. For example, you take out switch 4. So what will happen is the current will flow this way, right? Because all of these connected. Okay, flow through all these bulbs. How many bulbs will on? If you take out switch 4, 4 bulbs will be on. Am I right? This is how it works, because this side on the right, these 2 bulbs are not connected. They are not complete circuits. So this is how we do it. So the answer is switch 3, because the moment you take out switch 3, the current don't go to all these 4 bulbs. It only goes to 2 bulbs. So only 2 bulbs will be on. which is the least number. And the other two, you have to try yourself, right? Switch 1 and switch 2, what will happen? If you off switch 1 and switch 2, what will happen? You can take your own time and figure it out, because I'm going to upload this onto the website anyway after the lesson. So for those of you who are fast, very good. For those of you who are slow, you catch up when you get a copy of the slides on the website. Okay, so answer is C. I know all of you tried already, so very good. Those of you who are getting the hang of it, is okay. You just learn to be faster next time. Maybe the next question. Shall we go? 1, 2, 3, go. Whoa, okay, now I got to read. You got 4 pupils in the school or in the classroom who have a couple of items on their table, and were told to set up a circuit that could test if the batteries are flat. You need to see whether their batteries are flat or not. So they need to do a complete circuit. If not, they cannot test. So which of them have the correct electrical parts to test if the battery works? Who has it? So go and look at Ali. What does he have? Go and look at Ben. What does he have? Each one of them have the correct tools to check. In order to do a complete circuit, what do you need? You need battery, right? So good. Definitely the first thing you need is battery. And you need wires. Okay? So Ben doesn't have a battery. So he cannot be the one. And Carl doesn't have wires. So he also can't do the experiment. Okay? You got it? So only Ali and Deana can. And what does Ali have? Ali has a switch. Very good. But Deana doesn't have a switch. Is a switch important? Can she test without a switch? That's the question. So now the answer is Ali only, or Ali and Deana only. How many of you say is A? Figure it out. All you need to know is whether the switch is needed or not. Okay, so those of you who know switch is not needed will know that. Deana also can conduct the experiment. But then they might think, oh, she doesn't have a bulb either. Do you need a bulb? As long as the battery can connect to a component that can switch on the light or switch on a sound, it's okay. So Deana doesn't have a switch, it's okay. She doesn't have a bulb, it's okay, because she has a bell. And the bell can be made to ring if the battery is connected. So therefore, she can also be correct. So those of you chose A, you're wrong. The answer should be C, because switch is not the most important. And all electric circuit does not need to have only bulb. Then in this whole world, you only switch on your light, is it? You don't switch on microwave, you don't switch on, what do you call, your fridge, you don't switch on your TV. You switch on everything. So you can switch on anything, you can test the battery, right? Even your toy car, you can switch on. Is it called a bulb? No. You can test the battery using a toy car. So for example, I have a toy car, I can put the battery in, right? And then in that case, do you need wires? You don't, right? If so, maybe if you have a toy car, then the whole thing will change. You don't need wires also. You just need a battery and a toy car, because the toy car inside already is wired. Great. Question 4. You guys are getting better at this. So let me see how well you answer this then. This needs you to read all the 4 statements, A, B, C, D, and decide for yourself which one is correct, which one is true, which one is false. And then you can pick an answer A, B, C, D. Okay. So those of you who don't come to class with a pen and paper, you know that you should, then you can write down. Okay, at this point you can write down like, oh, A is true, B is false. Then you can make a conclusion. Guys, are you all done? Okay, good. Who's going to want to share your answers with me? Put up your hand and I'll call you. I want to hear your voice also. I've been seeing you type. Okay, many of you type C, some type D. Brandon said, I'll go with D. Is it D? D is A, B, D only. All of them are true. You need to go one by one to say which is true, which is false, right? Okay. Let's hear somebody's voice, just so you can hear somebody's voice other than mine.
Yes, teacher.
Yes, I can hear from Chloe now. Chloe, hi.
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 Okay.
Did you do the question number 4?
I'm still thinking. Hold on.
No problem. This is not easy one. Looks like we may have to spend some time to discuss this later, okay? No problem.
Okay, I think the answer is B.
D, yeah?
B.
D for Denmark?
B for ball.
B for ball. Okay, A and D is correct. Chloe says E and D. A and D is correct.
And teacher, I still want to ask you, some symbols like from my school for the electric circuit is a bit different from yours.
Yeah, I know. Like which one? The bulb, right?
Yeah, the bulb.
And the rest are the same, right?
Yeah.
Yeah, okay. No problem. I will answer that to the whole class. Thanks, Chloe.
Okay, thank you.
Okay, so who said A? Siu Mei said A. I'm gonna just write down the responses I'm getting so that Brandon said D, and he said others also. Brandon, what's your answer? Wait, let's ask Brandon. Brandon, what's your answer?
Well, originally it was D, but I changed to A.
Okay, thanks. That's why you see, originally it's D, then he changed to A. That means it's confusing you guys. So can you imagine you have this question in your exam and you really want to get it right? Okay, you really want to get it right because 1 mark loss is like 10 marks loss. If over 40 questions you do, every 4 questions you get 1 wrong, then over 40 questions you get what? 1/4 wrong, so you get 10 wrong. Wow. So you can get 10 mistakes just by getting 1 out of 4 wrong. You get what I mean? I'm doing fractions here. Every 10 questions, if you get 1 wrong, no, you won't get 10 wrong, you get 4 wrongs. So after 40 questions, you get 4 wrong. You lost 4 marks. Okay, so you don't want to get any wrong. That's the attitude we all want to have, right? Even me. So we have been having answers like A and B and C and D. Okay, let's erase all this and let's discuss slowly, since this question needs a bit of effort to work it out. So we just need to read. Okay, I teach you the technique. This time, whenever you need which of the statements are true or false, right? You just need to write whether it's true or false. Is it true or false? Is it true or false? Is it true or false? And then you look for the answer. And then you might have to do it again 1 more time just to make sure the correct one is true and the wrong one is false, just to make sure. Okay. So let's look at A. Statement A says when S4, which is switch 4, is open. Okay, therefore, I help you by doing this. I should use a red color for you to see. Okay, now this switch is open. So this is the way it's connected. Okay, it's open. So the rest of them are closed, right? B1, B2, B3 will light up. Looks like yes, right? So it's true. Am I right? Because B4 will not light up because something happened. You can see from the diagram straight away now. So you should adopt this drawing method and then later you can erase, which means you must use a pencil. Then S1 can be used to control all the bulbs in the circuit. Looks like it, right? Because if you take out S1 and you make it open like this, like I've drawn, then the current cannot reach back to the battery, which means all the bulbs will be in an open circuit, will not be closed. You look here, you reach here and it's open. Because everything goes through, must reach the battery. The battery is the start and finish. So it may go through everything, but when coming to finish, it's left here. It's open, cannot touch the other one. So S1 can be used to control. Yes, it can be used. So B is correct also. Okay, just follow on. Just since you all are confused, please keep up with what I'm trying to discuss with you guys. So I've already done 2. Now, C, when B1 is fused, the rest of the bulbs can still light up. Okay, let's look at it. Now, this is when B1 is fused. B1 is fused. This is I think we all struggle with this one. What happened is fuse is the filament actually blows, but the connection is still there, right? Connection is still there. So therefore, it doesn't matter what happens here. Even if you take that away, the connection is still having a battery here, and it's running through here, and there's a metal contact here, and you can run to the next bulb, which can switch on. Okay, as long as it complete here. Of course, I'm drawing like that. Okay, so it doesn't matter if it fuses, it can still flow through the metal contacts. Can or cannot? Is false, right? Because it cannot have this part here, the fuse already. So there's no way you can light up. So it's actually a block. So it's false. And when B3 is fused, the rest of the bulbs can light up. B3 means this one. So you basically take this whole thing out. The rest of the bulbs can still light up because there is a wire going through and doesn't have to go through the center portion. Whereas B1 light up, it has to go through B1. So you got no choice, has to go through B1. If B1 is spoiled, then all the other bulbs will light up. Understand? So that's the difference between C and D. So it should be this way. So only one is false, the rest are true. So A, B, and D only are true. Got it? So this is an example of how when one bulb fuses, it means it spoils in the circuit, then that is a spoiled part, becomes open there. So B1, unfortunately, is in the route taken to go to reach B2, B3, B4. Whereas B3 is just a sub-route. That journey doesn't need to take place. You can still go to B2 and still complete the journey. And then you can, okay, I'll show you how, why D can, because it's important. So you can go this way and you still go back to the battery, and you can still go this way and still go back to the battery. So it doesn't have to have B3. You can still work, and B2, B1, B4 will all still be on. Whereas if the other way, if B1 is spoiled, then there's a connection loss right here. This part, there's an open circuit. Same thing when the switch was open here. Okay, so you cannot have anything open near the battery where it's especially going to finish or start. That's the key, okay, criteria. Whereas at all the other parts, you can check whether there's still a possibility. That just like a road, right? If a road is closed, can you take another road to go? Can. But if B1 road is closed, you cannot go back to the battery at all. You understand? You understand? So imagine you are driving in a car. You like maze, right? So you're driving in a car, and then you go here, already blocked, it's spoiled, cannot go anywhere. But if B3 is spoiled, it's okay. You still can go through B1, go through B2, go through B4. Okay, great. Okay, next one. Diagrams below show how the batteries have been arranged in a torch. Which of the arrangement will the bulb light up? This is the same as question 1, so you guys can go very fast. Okay, all you have to do is see whether their contact, the contact is correct or not. Is the bulb touching at the right metal contacts? Is the battery touching at the metal right contacts? Is it touching at the positive terminal, negative terminal, or anyhow touching anywhere? And lastly, if they're all connected correctly, you ask your questions. The 2 batteries connected correctly to each other. Okay, to each other. What that means is when you have a battery here, and you have two batteries and you want to connect by wire, what happens is positive must go to negative. Then positive must go to the bulb. Then from the tip must go back to the negative. Can you see? So therefore, this must be positive and the connection here must be negative. That is why when we place the battery in another way, we place it like this. Am I right? Because the positive touch the negative. Same way here. If you do with a wire, you connect it this way. If you don't want a wire, you can save the wire by just making it touch. Therefore, one of the diagrams only is correct. The other two is wrong. Based on the battery touching each other. Which one is wrong? Which one is correct? Only C is correct. Same as mine, right? So C is correct. Only C is correct. The rest, A and B, are wrong because of the way they are placed. Positive touching positive or negative touching negative cannot. It must be positive touching negative. That is correct. Okay. Final question, number 6. Study the circuits below. Actually, it's not really the final. Final MCQ question. Okay. There is still a few more questions, but those are not MCQs. Okay. Study the circuit shown below. In which circuit will the bulb not light up? Again, it's just by now you're an expert. You tell me which one will not light up. I'm going to call on somebody here today. I'm going to call. This one I have to call already because I need to know whether all of you are good in this. So be prepared to be called. Could be anyone. Could be Victoria, Usha, Sumi, Sriram, Sophie, Shanice, Micah, Brandon, Branson, Celine, Chloe. Okay, go. I won't disturb you. I'll mute myself. I give you one minute. Okay, 1 minute is over. Aishwarya. Hi, Aishwarya. I only can see.
Sorry, I just joined.
Okay, so are you able to tell me what parts of the bulb must be connected in order for the bulb to be switched on? I've already drawn it there. Can you see number 1 and number 2 on the slide in my drawing?
Yes.
Yeah. So wires must touch the metal cap and must touch the tip. So in which of the diagram is touched wrongly?
B and C.
Very good. Thanks. So it's quite easy actually, right, Aishwarya? Okay, she's got it. It's B and C is wrong. So you guys have to have very sharp eyes. How many wear glasses? Okay, if you don't wear glasses, then you can't see. Then you have to start wearing glasses. You have to be sharp-eyed for this kind of questions to be able to pick up where the wires are actually going. Some of it can be actually be confusing, like you don't really know where the wires are going. Okay, so you need to pick up where exactly the touching, the contact point is. Sometimes you don't need wires, sometimes you just need to touch. Like I said, the batteries earlier, I showed you, you don't really need wire to connect from the positive to the negative. You just need to touch them. So either you touch or use a wire to connect. Okay, these two possible. So here you are touching, and if it's touching at the wrong points, how can you be touching on the glass of the bulb? It can't be. And if both the wires are touching both the cap, then it's wrong. If both are touching both the tip, then it's wrong. Okay. Similarly, you have to know how to connect it correctly. And when you go to the lab, I hope your teacher brings you to the lab to do electrical experiments, or you may have already done so. Then you get a chance to touch these wires onto a real bulb, and then you can figure out and you can see for yourself it doesn't work when you try to touch both at the cap or both at the tip, and then you will be able to appreciate it better. So which one will not light up? Question, please take note. You know how some people get this question wrong? Because it's not light up. So it's B and C. If light up is A and D. So you might choose A and D as light up. Then you put C as the answer. Then teacher will say wrong. Why? You didn't read the question. Am I right? This can happen to many of us. And it happens very often, 50% of the time. In a class of 10, 5 people get it wrong because they did not read the question properly. They just thought which one will light up. Because in your mind, you are reading the question faster than what is actually on the screen or on the paper. So you have to double check each time to make sure you are answering the correct thing. Not light up or not light up. True or false. Sometimes they say which of the following are false. Sometimes they tell you which of the following are true. And then you got a lot of. Okay, so answer is B instead of C. Yeah? Please take note. And that is answer for the last MCQ question. I'm going to go and try and get you to answer some open-ended as well. So that should bring us nicely to 4 o'clock and we can end the class. For those of you who are really tired from school today, I know primary 5, primary 6 is really tiring. Teachers are giving you a lot of work, but what to do? PSLE is coming for P6. And we have to be prepared. Okay, but rather than you study on your own at home, you rather log in every week at 3 o'clock. You come and see me, you meet a few people, you hear me talk, nonsense, not nonsense, sensical stuff like this. We go through, you actually can input more information in your brain and store it there than if you're trying to revise yourself, because by yourself, you are actually a bit lost, you're tired, you may be sleepy. But in the class, you feel a little bit of energy, a little bit of motivation to actually learn something that you're supposed to know for your PSLE, which means electricity is going to be easy, bulb is going to be easy, skeleton is going to be easy, respiratory is going to be easy. All those things that Ali covered in the few weeks, in this last few weeks, is going to be easy. And not to worry, I'm going to be here for the next few weeks until your PSLE, hopefully, and then we cover everything, and then everything is easy. Then you go in without being nervous. You know, a lot of people are nervous before the exam because they're not sure whether they will do well or not. But if you know you will do well because you tender all the questions, then you're not going to be that nervous, and then you're going to do well, really. Okay, that's just 1 minute of motivation talk for you. Okay, those of you already started the question. Hui Shan connected a circuit as shown in the diagram. Explain why the bulb does not light up in circuit. Why? Now, this is not MCQ, so therefore you have to actually write. Now, this is another technique that is required of you in the exams, which you are not familiar with. You know the answer. Okay, many of you know the answer, but you are not having the ability to write it well to get that mark. Okay, so you need practice. If you practice, you will get it right. Okay, how do we actually mention what you want to say in your mind? Okay, let's read it together. Okay, I want to take someone to help me read. Okay, let's try Jarek. Jarek, how are you? Are you sleeping? You want to read?
I just here to spend money.
Jarek just went off because he was listening to something else. You see, he's not even concentrating in the class. Jarek, are you there? Jarek. Yes. Okay, hi Jarek. I heard something else. Were you watching something?
I was taking a look at something else.
Okay, no problem. Now we are on this question 7. Are you able to read? Just read for me the answer.
Both ends of the wire were connected to the metal casing of the bulb. One end of the wire should have been connected to the metal tip of the bulb instead.
Yes. Okay. Okay. All of you understood that, right? So it's the problem with, let's choose a red color and say this one should go here. Am I right? So since it did not go here, it is connected wrongly. Okay. So metal casing. Okay, there's the casing. And there's the tip. Okay. Now, Hui Shan connected the circuit still there. What should we do, right? He made the changes to ensure that the bulb will light up and then added a switch at position X. Okay, position X is here. he's going to add a switch here. So it's going to look like this. A switch will look like this. Okay, maybe we can do that. Right? Okay. What will happen when the switch is closed? Explain the function of the switch. Oh, the bulb will light up. Okay, also he made the changes to ensure that the bulb will light up. He made the changes. That means he made this change also. Did he? So what will happen when the switch is closed? The bulb will light up. Okay, that's answer number 1. Number 2, what does the switch do? Allows her to open and close the circuit. Function of switch is important to know. So we're asking you the function of switch through this question. Okay, easy ones. Wow, what's this? Is it some Lego? Some maze? Fred, who's an interesting science happening guy, he's actually loves science, and he started to build this circuit maze with strips of paper on a cardboard as shown below. And the 4 corners W, X, Y, and Z are made of aluminium foil. Aluminium is a metal, so it should be okay if it touches the aluminium foil, right? When he tried testing the circuit maze, the bulb did not light up. Why did the bulb not light up? There's one clue in the question to tell you why the bulb did not light up. Tell me that word. What is the word in the question? Fred made a circuit maze. Which word? Can you type for me? There's one word in the circuit. Why did it not light up? He did a mistake, something. W, X, Y, and Z are all metal. The bulb is okay. Oops, is it connected? Even the bulb is not connected properly, right? Is it both connected to the casing? Yes. So this one is connected both to the casing. That's one reason. What's the other reason? Okay, you see you have one preferred answer and one possible answer also. Let's read. The strips of paper are not conductors of electricity. Yes, that was what I was looking for. I said it's in the question. In the question, you see, you use paper. How can you use paper for electricity to flow through? So that's why it will go until W, but then beyond that, all these parts, right, it won't go through because this is all paper. And of course, they are not connected also. They are not even complete. Look at W, it's not even complete. It's not touching another piece of paper. So therefore, it will be an open circuit. So there are many answers to this question, like he's using paper, the circuit is not complete, and the bulb is not on the right contact. The bulb is not connected to the wires properly also because it's connected to the glass bulb instead of the metal tip, creating an open circuit again. How many answers are there? 3 different types of answers. One is you use paper, which is a electrical insulator, does not allow electricity to pass through. 2, what? It's not even complete because the paper, even though he used paper, he must make sure they all touch and finish off at the battery. The 2, you must start and go back to the battery, but it's not going back to the battery. There's some kind of breakage at this point here where I drew in red color. I colored it in. And lastly, of course, the bulbs were not connected correctly. So you can get up to 3 marks. You can say, we can change this question and say, state 3 reasons, 3 different reasons why Fred's circuit will not work. And then you can tell me 3 reasons, I give you 3 marks. Isn't that nice? Nice. Okay. What is a possible solution for Fred to solve the problem? You must replace the strips of paper with strips of aluminium foil, or you can connect the end of the wire that is connected to the glass bulb to the metal tip instead. In fact, he should do both, right? He should do both. Then only can he sort out the problems in his circuit. Okay, so that's the solution. When Fred fixed the problem, which 2 corners should Fred connect the wires so that the bulb will light up? Explain. Looks like it's not W and X because, like I said, if you connect W, you create an open circuit, right? It doesn't connect anymore. So maybe we should take out W. We shouldn't use W. We should use something that is connected back to the, and is touching. That means it's connected. So which 2 alphabets are touching each other? X, is it touching Z? Yes. You see here, but here there's a break. Can you see there's a break here? Okay, so which two alphabets are touching each other? X and Z are touching each other. So therefore, you should take this wire and go to Z, and then they are touching each other, right? Okay, you should connect corners X and Z. That is the answer, because only those two corners touch each other. The rest, there will be open circuit. All right, fine. Question 9. The electric circuit below is made up of 4 bulbs and some wires and some batteries. It's observed that after setting it up, all the bulbs light up. So very good. Whoever this student did this experiment, very good. Explain what will happen to the other 3 bulbs if bulb B is removed. Ta-da! Now this is the question. So will the 3 bulbs light up? Okay, let's see. Bulb A, bulb C, and bulb D. Will they light up or not light up? Check. If B is gone, will they all light up? Let's run through the wiring to see if they are actually going through all the bulbs. Yes, current will flow. Yes, current will flow. Yes, look at, just follow my arrow, follow my red line. Current will flow. It doesn't matter if B is gone, it won't go there. Current will flow and you will reach the battery. Voila, happy, yay! Reach the end. You must start and reach the end of the battery. If can, then good. Don't care about the rest which are going in between. You don't have to use that row. Okay, so that is okay. So all 3 bulbs will light up. Doesn't matter. Okay, so when bulb B was removed, there was a closed circuit. Okay, thus electricity will still be able to flow through the other bulbs. The key answer is there will still be a closed circuit. There will not be any open circuit, and then therefore all the bulbs will still light up, and also allowing A, C, and D to be inside that closed circuit also. If any one of the bulbs belong to an open circuit, then that bulb will not light up. Okay, very good. It is observed that all the lights bulb light up. Now the B is back in again. Lin decided, now somebody called Lin suddenly comes. Just now nobody's name was there. Lin decided to install a switch to control all the bulbs. Mark a cross on the circuit above to show where the switch should be placed. Must control all the bulbs. So when you place it, you must on, all bulb will light up. When you off, all the bulb will be off. So where should we put the X? Whenever you want to take major control of the whole circuit, you should always place it near the battery. Okay, recommended that you put at the start where the battery is flowing, because there's some energy saved. You're not allowing the current to pass through all the way. If you put the switch here, it's not wrong either. Okay, because you still can create an open circuit by putting it here. Because once you open, current cannot reach the batteries, so therefore it will still be open circuit for all the bulbs. So since it's all the bulbs, therefore you need to put it near the batteries. For example, if you want to switch off only one bulb, then let's say only bulb B, then you put the switch here near the bulb. If you want to switch off only one bulb, you put it near the bulb. Okay, so bulb B will be off. How about here? If you put here, what will happen? And you leave it open. Current is going to flow this way. And you're going to switch off 2 bulbs actually. You're going to switch off 2 bulbs. C and D will be off. So you need to be able to mark a cross, right? So instead of drawing the switch, some of you thinking, so must actually put a cross over there. Okay, great. So the cross is over here, just before it goes closer to the batteries, and it should usually be at the start of the positive terminal, where the positive terminal. It's not recommended for you to put it over here. Okay, it's wrong. It's not say wrong, but we recommend you to put it at the start, because you conserve the electricity from flying by just switching on and off right at the start. Okay. Last question. Don't worry, Brendan. I know you're tired. You want to go and sleep, Brendan. Brendan has been asking me all day when I'm going to finish. Brendan. Okay. Next week, maybe we should all switch on our videos and see each other's faces. Then I know all of you are here alive, not sleeping. Oh, sleeping. Some of you are already sleeping. Some of you watching YouTube. No lah. Of course you're not watching YouTube. Because you can watch YouTube after this one. After 4 o'clock, you can still go and watch. Why do you want to watch YouTube now, right? You can might as well learn something now. Or if you really don't want to learn, you might as well switch off, leave the meeting and go and watch YouTube. So I don't understand why you should be in my class and still watch YouTube. It's pointless. If you don't want to be here, you just press leave and you are out of here. Easy. Okay. Last one. Very easy question. Bumper cars. I don't know how many of you have tried bumper cars. There are a lot of modern cars where you get into the car, you press on a certain pedal, the car will start to move. And then if you let go of the pedal, so it's very easy, much easier than driving your dad's or mommy's car. Okay? Because children need to be able to do it. So there's no brake and there's no gear, there's nothing. There's just one pedal. You put your leg on it, it will move. If you take your leg away, it will stop. Very easy. Okay? You put your leg, you press more with more force, you probably go faster, right? So you probably allow more current to go in. So actually that's acting as a switch to complete a circuit. Your pedal is completing an electric circuit to allow the car to move. It's exactly like a toy car. You put a battery in, it moves. You take the battery out, it does not move, right? Or even if you move it a little bit out, it does not move. What does that mean? You are opening and closing the circuit. The contact is lost. So same thing with the bumper car. You put your foot down, there's contact. When you take your foot off, there's no contact. It becomes an open circuit. So similarly, so we put this question in. We draw a diagram, and so complicated diagram, which is, okay, you can read it or don't read it. But question is how a bumper car is able to move when the pedal is pressed down to touch contact C. Okay, so you have the battery and you have the wiring and you have your contact C, which is your leg, which is here. Can you see? This is where the contact is. This is where you press, it will contact this part here. Correct? The pedal and the contact will touch each other. If you don't press, it doesn't contact, then the circuit is still open. Okay, enough of me talking. You know the answer already. The answer is when the pedal touches contact C, there is a closed circuit. This allows electric current to flow through the motor and therefore the car can move. This is how you explain for 2 marks. Explain for 2 precious marks. If you say explain and then you don't explain, you just say, oh, if the pedal will touch contact C, then it's not enough. You'll get probably 1 mark or not even, only half mark. You must say when you touch contact C, what will happen? Then the circuit will become closed. Then the electricity will flow. Then the car will move because the electricity is flowing. This is full explanation. So this is why I say point 1, point 2, point 3, point 4. And similarly for all the open-ended questions, I did write down point 1, point 2, point 3, point 4. So if you want to pick out the exact points to score, you need to go through the answers in detail like what I have picked out, and you have to go and download these slides which I upload today, tonight, or tomorrow morning when you wake up, or tomorrow when you come back from school. Just download the PDF that I have for you on the website, go through this again, or just save it somewhere in your computer, on your phone, to look through how to answer open-ended questions. And then next week, we will be looking at the second part of electricity, which is to put bulbs in series and parallel, to put batteries and add more symbols, to add more components to the circuit, and also the safe use of electricity. So that's next week's lesson. And there may not be homework because you have done the homework already. Those of you, that's my reward for those of you hardworking students. The homework for next week's lesson will be the same as this week's homework. Okay, so you don't have to do any homework. But those of you who did not do any homework, you lazy buggers. Now you have to pick up on the homework and do it this time around to catch up for next week. So make sure you do it, and I'll see you in a week's time. 7 days to go, but it's very fast. Bye-bye.